My name is Aaron Kirkey, and I'm from Niagara Falls, Canada. I'm a master's student at the Department of Chemistry here at the University of Alberta, and thank you for attending my talk. My research focuses on solar cells, or photovoltaics, but first let's talk about food. Imagine we wanted to make the best tasting sandwich possible. This isn't such an easy task because sandwiches are complex. They have many layers like meats and cheese, and some of these layers need to be heated or sliced like a tomato. So making every single recipe could take years. But if you were clever and you wanted to save a lot of time, a computer could help you out. So normally when we optimize something, we are just trying to make the best version of that thing. So we're trying to make, say, the tastiest sandwich possible. Normally when we do this, we can change one thing at a time, like the sauce or the meat, and we test it. You could change two things at once, but changing both the meat and the sauce, it would be hard to tell which one of those two things made the sandwich better or worse. Maybe both of them made it better or worse. And this is where a computer can help you out. So with the computer's help, you can change 2 or 3 or maybe even 4 things and test it. And then the computer would help you figure out what in the recipe made that sandwich better or worse. This means you could make significantly fewer sandwich recipes while still trying every single sauce, meat, cheese, or vegetable. And the computer would help you track down the best tasting recipe while saving you a lot of time and a lot of ingredients. And while sandwiches might not be able to help us fight climate change, solar cells could. So what is a solar cell? Solar cells are capable of turning sunlight directly into electricity, the same electricity that could be powering your laptop right now. And they do all of this without producing any carbon dioxide. And this is great. So why aren't there solar cells everywhere? The problem is they're pretty expensive, and people have been looking at making them cheaper for a long time. One way of making them cheaper is to make them a bit more efficient at turning this sunlight into electricity. So the more efficient the solar cell is, the cheaper it is. So on the left on this slide, we have what we normally see for solar cells. These big dark blue tiles on rooftops or in farmers' fields. And they can be very heavy, and as a result, they're hard to install. But I work on a new type of solar cell, the one shown on the right. It's an organic solar cell, and these can be made as thin and as flexible as a credit card. However, they also contain a lot of layers, much like a sandwich. And each of these layers needs to be made in a specific way for it to produce as much electricity as possible. So my colleagues and I have developed a method with the help of computer algorithms you can think of as just a lot of math on a computer to help us decide or help us figure out which recipes among hundreds could make the best solar cells possible. So these 2 pictures here are from devices actually made in our lab. And you can see that they're quite small, and they're also very, very thin. They're about a millimeter thick, so maybe 10 sheets of paper thick. So what we do when we are optimizing or trying to make the most efficient solar cell possible, we start by picking a few layers we want to improve, and we think of a few ways of actually improving those layers, say by heating them up, or by mixing in another ingredient. And once we've made a few solar cells with the help of the computer to decide which recipes specifically to make, we actually make them. And then we take those results after we've made them and tested them and put it back into a computer. And this computer helps us figure out which recipe makes the most efficient and therefore cheapest solar cell possible. So on this slide on the left, we have a topographical heat map of Edmonton. So if you look at the little color chart on the right of that image, you can see that areas with red or white coloring have the highest elevation, and areas with green or blue have the lowest elevation. And as you'd expect, the river valley, which goes right through the middle of Edmonton, has the lowest elevation. On the right, we have one of our machine learning computed or built maps. And it's the same idea, where if you look at the color bar on the right, this time the yellow areas are the highest, PCE, which is a short form for efficiency, which I had mentioned earlier. So the more efficient a cell is, the cheaper it can be made. And these blue areas, these dark blue areas, are lower efficiency. And so these maps, which are produced by the computer, help us figure out which recipe exactly could make the most efficient solar cell. So each of these colored dots are devices we actually made and tested in the lab, and they have slightly different recipes. And so if we could, we would probably make a device that would fit on the map in the top left corner. So as you can see on that map, that is the brightest yellow region, and so it would be the most efficient region, or the most efficient recipe would give you a dot somewhere in that top left corner. And that is the computer telling you which recipe would make the most efficient and therefore cheapest solar cell to make. Thank you very much for listening to my talk today.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.